Okay. Hello, everyone. Do you hear me well? People in the room? Okay. So this tutorial is about Scikit-learn. As you know, the next assignment, the third assignment, is going to be every class that you are going to use is based on the Scikit-learn. So you have to use that. And this tutorial is going to explain what is it actually and how you can call different modules from that. And and it's going to have like different kind of example that you need for the assignment. So it basically covers everything. Okay, so to know more about the general view of the what is Scikit-learn, so it has different kind of packages for data processing, feature selections, or extraction. For dimensionality reduction, for classification, clustering, and model selections, yeah.
Do we have access to this file?
Yes, that's sent it already in Piazza. For like hyperparameter tuning and this kind of things, you can easily use this package. So in this collab, there are going to be like different part of code that you need, and I'm going to run it and explain which part does what, and then we go further. And if you have any question, just like feel free to jump if I didn't see you. Okay. So first of all, we're gonna import different kind of library that we need. It's like basically pandas. Pandas is like a kind of like a structure, the data structure that we usually use that when we want to work with a data set. And like matplotlib is just basically the plot one kind of things that we use, and NumPy. So here we're just gonna load like a simple data set that's from Kaggle. And I just printed out like a few rows of that to see like what are the features and what are the labels here. As you see, like we just called it with the like PD means like the Panda format that like we use just Panda to load it. So this is the simple one. I'm not gonna like talk about detail of the pandas, but just to know. Like here you can see that you have different features. This is like a user ID, and each user has like gender, age, like the estimation of the salary, and like at the end we want to see if it's gonna like purchase a product or not. So the last column is the label, which is gonna be a binary, like 0 or 1. Everything is good? Okay. So now there's a problem with this data set. What is the problem? Anyone can say it. Like basically it has both text and number. So we have to convert this text as well to a numerical representation. So one thing to do that is like Scikit-learn has also a function to do that. That is like a label encoder. One thing is just we can do this is not one-hot coding, but we can also do one-hot coding. But what happens here, it just assign one of them to a number. Like here, there is two category, male or female. It's gonna assign each of them to a number, 0 and 1. Like 1 is gonna be male, 0 is gonna be female. So that's the first step. Even in your assignment, you need to make sure that all of the features that you have, all of them are in a numerical, are not text. Okay, so then we have to like basically like separate features from the like labels. What we call with X is gonna be the features that we are gonna use it as input, and Y is gonna be the output of the classifier or the prediction that we want to have. So here, if you see like the like data, you can see the like the last column is gonna be the like Y, which is like we separate it out here with this line, and the rest of that is gonna be X, like which these are like feature that we have, and we start from 1 means because we don't want the user ID, because it's not gonna like give us like good information. Why then? That was a question for you, but I answered. So why? Because user ID is unique for each person, so it's not gonna cover convey any kind of good information about the classification that you want to discover. So we don't want that features. So we put the rest of the feature, these 3 columns, in X, and the rest is gonna, like the last one is gonna be Y that we put it here. So I just want to make sure that I run this one. And now I'm gonna run the cell as well. Okay. So the next step is gonna be like train and test. So do you know actually what kind of classification do you know until now? Like what is the last classification like method that you learn in the class? Yeah.
So call it in GND.
Okay, so you know test and train, like what we call train and what we call test.
Yes.
Okay. So right now, all of the data that we have is in one category. So we need to split like some of them for training, some of them for test. And we're gonna like train our class on the training data set, and we're gonna like evaluate our like learned like classifiers for the test data. So Scikit-learn also has this probability, this possibility. So that function is train test split. And we're gonna like define how much of the data we want to be for test. So 25 here means 25% of the data we want to separate it out for the like test, and the rest is gonna be for the training. And we just gonna like assign it for a random seed because like at the end we're gonna like have the same response for like when we run it different times. Okay. So it shows you that the output is gonna be like X, Y for X for train and test, Y for train and test. And as you can see, like for train, you have 300 number of examples, and each of them has 3 like features because that's X. But other problems is like with the features in the like that features in this data set or any kind of data set that we are using. So basically we need to like make sure that they are normalized. So there are multiple approaches that we can normalize a like feature of the data. So here we use like a standard scalar that we basically try to like fit them to a normal distribution. And we have also min-max approach that we are gonna like basically for like min-max, we are gonna like find the minimum, the difference between minimum and maximum of the values for each feature, and we're gonna like subtract the minimum value for each like data point that we have, and it's gonna give us the like new features, the like normalized features. So to try this, we just to show you how it works, we just created like a tiny example. So it has 4 samples, and which of them has basically 2 like features. I can say 2 values. We just want to see how this normalization work here. Okay, if we just, okay, this is what happened like theoretically. If we want to see like between these values, if you just subtract the maximum and minimum, and then for the like the second one, if we just subtract that from the minimum value, at the end, we're gonna have this value. So this is equal to like this value that we have at like the second row. But Scikit-learn also provide this like function for us. We can just simply like create like an objective from that, and then we can call it with fit transform. Okay, what does fit transform basically do here? So it's gonna like find the output of that is gonna be the normalized value, but we need also that for the test. So how we can, okay, first of all, should we like normalize both test and training data at the same time? Yeah, no, why? Yeah.
You want to avoid using the test data.
Yeah, exactly. So here, like this is a like a just, okay, there is something on the chat. Yeah, that's also right. So we basically use this function on the training data, and then we use those parameters of this like objective to on the test data. We will see the like the exact example on the data set that we have. Here is just with the tiny examples. Okay, what about a standard like version of that? So we basically find the standard deviation and the mean of the like the data set, the samples. We know the definition of these two from a stochastic course. So then for that one, if we just use like this function, find a like an objective from a standard scalar, and then again use fit transform and give the data as input to that, we're gonna have the scale data. Like this one is like just a standard version of that. It's like a standard normal of that version of the like I would say conversion of the data. So as you can see here, values are not between 0 and 1, right? Because of the normal distribution. So you can like, this might be important sometimes, but you need to know that, right? When it's good to use like min max, and when it's good to use just like a standard scale. So basically, here is 2 points that we say like when is better to use which of them. But it's not limited to these 2 points. Like basically, you need to see if the range of variables are very different from each other. You can see, like for example, like mix and like min and max. But for example, if they are very large, they are not very large. They are like in the scale of like 1, 2. You can use just normal distribution, but it's not limited to this one as well. Like there are more reasons. You can basically, I would say, try both of them, see which one is better. But for the data, so we learn both of them. So for data, we gonna use.
怎么没声呢？
Okay, could you please just yourself? So for the
我
data,
听一个人讲的课。 编号的3
Won't have access to that because I'm not the host. Okay. So Alice, if you hear me, could you please mute yourself? So it happens many times. Yeah. So okay, what about the data set? So for the data set, we just selected to do a standard scalar. So first we are gonna like define an objective from that, and we're gonna like use this objective and then like call feed transformer and then pass the training data set, the training like part of data that we consider, and then we're gonna like have the normalized one. And then again, we're gonna use that for the test data set. But we do like when we use this objective, it's used what like parameters it's already finds in the training and apply that for test. Like for example, for a standard scalar, so it's gonna use the same mean and standard deviation that it already find in the training data set, and it's gonna apply those values again on test. Even the test distribution could be a bit different from the training distribution. Okay, did you get it? Do you have any questions? Any feedback? Good. Okay, if you have any question, just like interrupt me because I don't know how much detail I should cover. Okay, so these two data, these two like variables, like this is, like these are right now the normalized version of the training data set and test data set. So this part is just like some plots that we like provided for you. So we're not gonna like go to the details of that because it's just, we want to use them for showing the classifiers later. Okay. Now assuming that we have data set for train and test. Yeah.
Should you also normalize the Y training or just the X?
Just X. Why not? Why do you think we should normalize label as well?
In our previous assignment, we had Y training or Y, so we had to normalize them.
Okay.
I don't know if it's the same for this case or.
Okay, maybe it depends on the like the problem. Most of the case, because it's binary or like a classifier should just print out like a number which is not very big. So we don't usually use that, but sometimes, yeah, there may be the number of class are like very large, and in that case you can just normalize that and then bring all of them between 0 and 1, and it might help. Yeah. Was there any other? Yeah.
I think it was in the case of a regression that it wasn't a classification. Do we standardize or normalize when it's a regression, also the labels?
Yeah, I think it's the same, basically. Yeah, we are gonna do that because, yeah, we want to make sure that the space that we are like searching for finding like boundary between the classes are like in a good region. Yeah. Okay, so given the right data set, now we want to like fit the model to the data and find the classifier.
Why we have to feed transform the trainer if we are transform the test part.
Yeah, because at this part, we are gonna use the train data set to find the parameters for the standardization, to normalization, I would say. For example, mean and like standard deviation, or for example, like mean and max of the data set. All of this information could be done on just training. Yeah. Okay, so now given the data set, we are gonna learn the train the classifier, the model that we have to find to have a classifier for that data set. Okay, first of all, we need to pick a classifier type. So there are many classifier in Scikit-learn. So maybe I can show you. Is there here a link? No. Okay. Actually, it's good to you can explore many kind of things here. Like you can see it has a lot of classifier here. For example, linear models. There are any kind of multiple classifier. I don't know, regression, whatever. Support vector machines, you're gonna use that for the assignment. It has also a ridge regression. So any kind of classifier that you think, most of them, I would say almost all of them are here. So you can use them. They're almost the same, the way that you are gonna use them, but their parameters are different. So you have to check the the tutorial of the Scikit-learn website as well. But one thing I wanted to say is that, okay, when you select the classifier, now you have to create an objective from that. Given that objective, you're gonna use that and then feed it to the data that you have for the training. You pass the features and the labels. So by this line, it's gonna learn the behavior of your data. It's gonna learn the classifier right now. So now if we use this objective and then just use predict here and then pass the feature of the test set, it's gonna predict us the Y labels. Let's do it. And then we can print it here. It's gonna print some rows of the, okay, it printed all of them. So, but we don't know how much of these labels are correct or wrong. So is there any question from this part? This part is the main things that you should do for any kind of classifier or classing. Yeah.
Can you repeat why do we do this part?
We want to any class that we want, that we have, we want to train that on the data set. So we just define an object from that, and then we just use the feed function and then pass the training data set to that. By this step, it's gonna learn the behavior of the data and you have the classifier right now. So at this step, it's gonna predict the label for the test set. Okay, so next step is how to evaluate if this classifier that we learned corrects well the labels for the test. Okay. Basically, we call this a step evaluation. For evaluation, there are different metrics that are well known to use that. Very simple thing is the accuracy score, which basically find how many of the labels are correct. But there are other kind of metrics. We're gonna learn that during the course, or maybe you already learned that. I don't know. But if you didn't, you're gonna learn it. So one of them, as I said, is accuracy score. So we can import these functions from metrics, metrics part of Scikit-learn. Okay, so now we want to find the accuracy, and then we will give it the correct labels from the test data and the predicted labels that these are the values that are predicted by the classifier. Basically we predict them here. So the difference between them like based on the function is defined here, it's gonna give us the accuracy of this model. We will also have confusion matrix. Do you know confusion matrix? No? Is it not in the class? Okay. You know like by your own. Okay. Okay, well, for confusion matrix, I can tell it what is it. It's not okay. Okay, let's run it first. Okay, the accuracy was like how many of these labels are correct. Like let's say 90% of these labels are correct. So that's actually a good accuracy. But confusion matrix says like how many of these labels are correct and how many of them are not correct. So this is like basically okay, saying here is like okay, label 1, label 2. This is like predictor. This is it says like how many of like predicted labels of label 1 is basically correct. Like for example, for this is like 60 something. 5. And three of these three of them are correct, are predicted for this should be predicted. Should be correct. No. Okay, these are like we have like 68 samples. From these 68 samples, like 65 of them are corrected for label 1, are predicted for label 1, which are correct, and 3 of them are predicted as label 2, which, for example, this is 0, 0, this is 1. So these are incorrect. So we call it confusion matrix because it shows like how much maybe like the classifier is confused. So this is like these are should be also predicted as L1, but it's predicted as L2. So it's kind of like these are the numbers that are confused. Like for example, for this part is like 7 and 25. Like 25 of prediction are correct, like exactly they predicted label 2, but 7 of them are predicted as label 1, which are incorrect. So did you get it or? Okay, what is the ideal version of classifier? What should be the numbers for the like the perfect classifier here? Yeah. Yeah, exactly. So this should be 0, 0, and then for example here we should have like all the number like 32 and yeah. Okay, so we learned about the accuracy as well. So now what is this? Okay, we just want to see like how this like predicted model is gonna work. Okay, it takes a time. I should have run it, but that's fine. Okay. So you can see that if the green dot shows like the class 1 and red dot shows the class 0, you can see that this is what the classifier learned. So it's gonna like categorize like this amount of red data in this region and this amount of like green data in that region. So you can see that it's actually it's kind of good classifier right now. Okay. Now we're gonna talk about K and N, K nearest neighbor. So I think you learned that, right? You said you learned that? Okay, so you know this one. So with that, we need to like this has a parameters. We need to find the like number of like neighbors that we want to use for the classifier. Like in this example, it used 2. Why 2 could be a good number? Yeah. But
With the question,
what 2 could be a good number?
if it's a smaller thing, you're getting like the closest one, and you can pick like 100, and you would take it all the neighbors, so it would be nothing.
Okay. But is there any heuristic here or any hint here? So I would say in most of the case, we can consider number of neighbors if we know the number of class for that data set. Like for example, for this data set, we know already that this is like it's a binary class, like binary data set, like the class are binary. So we're gonna like select 2 kernels because it's either like the data set either is like class 1 or class 2. But at some points you don't have like it's a clustering approach and you don't have it in that kind of set. Like you have to try it with different numbers and then see the accuracy for which of them is higher. Okay, so it is exactly the same as the previous like classifier. We first like define the objective function. We feed that like object. Yeah. That not objective function, object. And we feed data using that object. We're gonna use feed function and then train data set. And then we're gonna use the predict function and then pass the test data set to get the predictions. This is again the accuracy. I need to run it. But this was defined. X should be a small maybe. Oh, okay. I think it restarts my lab. Just 1 moment. Okay, you can see the accuracy is again like 90% and the coefficient matrix is like that. So it's still a good model. There are, I think, multiple other kind of like logistic regression, again, the same. Other kind of classification. Like you are gonna use like support vector classifier here. And also in your assignment, you can look at to this part, but it's again the same as the like what we saw. Okay, so there is okay, we're gonna like talk about hyperparameter tuning right now. What time is it? Okay. Okay, so we learned right now we still have to like split data set, how to like fit a classifier to the model, have to like evaluate the model based on some metrics. And now we want to see, okay, before going to that one, let's be like have a discussion with each other. So how we know if the parameters of the models are good? Like each models has a like a kind of parameter. Like for example, number of neighbors for K and N. Or like for example, like the learning rate that you're gonna like select for that, like in the if you want to train like a network. Or like there are gonna be some parameters here that you don't know the exact value of that it's gonna work best for your data. So what's your suggestion to find a good value for those parameters? So first of all, did you get what kind of parameters I mean? Yes or no? Okay. So we call those parameters as hyperparameters, the parameters that are part of the like the model or part of the training, and we don't know a good value for that. Then what are your suggestions? Yeah,
We can try different values at different scales.
different values at different scales.
If we try a value of 10, next turn we can try 1,000 and see which order of magnitude is better.
Okay, and what about data? Do you think we don't, okay, assuming we don't have access to the test data set, how we can see like which one is better? Wait.
Try on the validation set.
Hmm?
Retry it on the validation set.
Yeah, but let's wait. I want to see more answers. That's correct, but I want to see more answers. What is validation set?
It's a set where you try macro parameters to see if they fit well the data before trying on the test.
Okay, but yeah, sort of. Okay, so okay, assuming we don't have test data set, we want to like somehow find a good like value for these parameters for the model. But we don't want to also use like the data that the model is trained on, because in that case, like the model is fed to the trained data set and you're like, it's gonna work well for the trained data set, right? So we're gonna use cross validation. So what is cross validation? So basically, so for all data, we already split it to like training data and test data. Now we're gonna like ignore test data and we're gonna like just work the training data set. For training data set, we can like do multiple things. So one approach is that, for example, we like split it to 5 parts or n parts. And then we call like, we're gonna like train on each of these versions. And then we're gonna like consider every time each of these parts as the test, like It's not a real test data, but we assume that this is the test data, and we're gonna like evaluate our models on that part. So we call it cross validation. Maybe just can write it. Maybe it's okay. Like for example, I consider like n equal to 4, like I have 4 like estimates of the training data. For the first one, I just like split out the first part of test data, and then I'm going to find like the accuracy that I'm going to feed the model to each part. And then it's going to give me some accuracy, but here it also give me another accuracy. So if this accuracy is good, I can say, okay, these parameters that I use for fitting the like model that is like parameter. So again, I'm doing the same thing, but this time, but I have 4 parts, right? This time I consider this one as a test, and again find the accuracy here. Next time I'm going to do for the third part, and next time I'm going to consider the fourth part. For each of part, I calculate the accuracy and then an average or like a stochastic combination of these like accuracy can like tell me these parameters that is equal to x1. The x1 is a good value for this data set. We call it like cross validation, and like Scikit-learn also has this one. That comes to the like k-fold. Like basically we call it like k-fold. Like basically we have fold like part, and like each part is gonna call as a fold, and then k is the number of these fold. Like here is like 5-fold. Like let's see that for the like a very like basic examples. Like for example, here we have like let's say like the x is like a range of values between like 1 to 11, and you have like their corresponding like y's. They like assume like these are like the labels of these 11 values. So okay, you're gonna call k-fold from like model selection. And then you're gonna select, okay, how many like fold you want to have. Like here, for example, it selects 2. Like in these examples, it's 5. Like you should put this value to 5. And then you're gonna select if you want your data to be shuffled or not. Okay, so then for that, you're gonna like see what is the like values of y for each of these like fold, because there's 2 fold, so you're gonna have 2 predictions, 2 like row of predictions. That's why like you have this for the first one and you have this for the second one. Okay, we can compare it to that, but it's not very. Okay. So it just shows like what are in the like the train and what are selected as tests, and here what are for the train and what are selected as tests. This is a certified k-fold, which okay. So what is the problem of this kind of like k-folds? what could happen for the distribution of the data set? What could be wrong with this type of like doing splitting and then k-fold kind of things? Do you have an idea? Yes.
If you pull the data, we could have all the same tables into one fold, and so we wouldn't not train on them and have them in the validation test first thing.
Yeah, shuffling is important, but there is another thing. So you mentioned that, but that's different from shuffling, but you mentioned that one. Was there anyone from here?
What you said that the problem is that it's not shuffled, so it might not have the same representative distribution in each fold. But I don't know if that's what he said.
Yeah, like you are saying the same thing, but it's again, it's not gonna like be solved by shuffling. Shuffling is necessarily at some points, but for that one, we need to somehow like make sure that also the like distribution of each samples are in each like category. And a certified is gonna like do that for us. Like shuffling is necessary, but it's not enough. If we put like shuffling true here, but again doesn't use a certified like k-fold, it's not gonna do that for us. Okay, so basically the right thing is that just call this function and use a certified k-fold. Again, the same things. And right now you're gonna have that you have like, if you compare right now these like data, I don't know, samples with these that you have above, you can see like for a train, it's just have like C, or here many of them is A. But if you compare it with this part, you can see that you have at least like different like samples from different examples. And it's also depend on the first distribution of the data. Like, I mean, this distribution, if you like sample C is more than sample B, or sample B is less than sample A, it's gonna care about that as well in the folds. Okay, so that was one important thing. And now is that, okay, let's say we now have this kind of fold. Now we want to like fit the model for different kind of these values. Like we want to change x1 to different values. Like for example, for k and n, we want to change the two number of neighbors to different values to see like which one is the best one. One simple thing that again this library provided for us is like grid search with cross-validation. So basically we're gonna define the parameters that we want to change their values here. So we're gonna like call it like hyperparameters. And here you're gonna just pass the values to this parameter. Like for example, for number of neighbors, you think like any of these numbers could be good for that. So you're gonna consider a range of numbers for that, and then give it to the as a values for these parameters, and for P as well. So then here again, you call the certified for the data set. You're gonna like select 3-4, and then you're gonna use the grid search. Given the classifier, given these parameters that you defined here just above, and then you're gonna select an accurate and like a metric here, which is accuracy here. You can change it to any like F1 score or any other kind of a score that you want. And then here you're gonna say what is the like cross validation, which we already defined threefold. So we are gonna pass it here. And then at the end of this step, this grid search is gonna this is basically an objective, and when you just pass the train data set to that, it's gonna like give us like which combination of these two parameters are the best for this data set. If we just run it, we're gonna okay, to see what are these parameters, like you can use best param, like grid search like best param, and then it's gonna give us like best parameters. So basically you can find number of neighbors with 5 and p equal to 2 is like good for this data set. Here is just, okay, we have model, I don't know that's how much it's gonna be, okay. And if you see, like here, it's just gonna like show you the like result for each of these like combination that the grid search had. Like for example, for neighbor 1 and P1, this is the accuracy that it has. For neighbor 1 and P equal to 2, this is the accuracy. This just print out what are the accuracy for each combination of those parameters. And this is just the classification report. You can at the end, like just report this classification, and it's gonna give you all of the information that you need. For example, like okay, this is okay. Before that, let me if I okay, now you have the best parameters and you want to see what are the prediction of those parameters based on the data. If you use grid search and predict and then pass the features for test, you're gonna have the prediction, like Y prediction. And then if you pass the prediction Y and the correct label from the data set to classification report, you're gonna have this kind of reports that I think like you will learn these kind of like metrics later in the course if you don't know them, right? Do you know them? Okay. Yes or no? Okay, it's supposed to be okay. Okay, let's stop here and then see if you have any question. Then I can see like how much we have time if you want to go to the linear regression, but that's part is easier actually. Okay, if you have any question from like hyperparameter tuning, anything, like let me know, because yeah, you will have to have an assignment for that. No? Thanks for the feedback, you are done. If any part is like hard or you think I should explain it more, just tell me. Basically, your third assignment is gonna be like using like Scikit-learn and then call like different kind of classification and exactly do the same things that I did. Like you need first like feed that to the, like you need first like split your data set, like normalize it, split that, and use classifier to feed the model to them. And then you're gonna use cross validation and then find the hyperparameter for that. Exactly this like steps that we did, and then report like different kind of metrics.
Can you explain again, you're going to stratify the K-fold, the answer to the problem why we have the problem that wasn't solved by shuttling, but I didn't understand really answer. Can you explain again?
Yeah, for like if you look at like this like you can see here in one part it put like all of the C labels, and on the other parts it puts A and B. Okay, So, but it doesn't have any AB here or any C here. So then in the training, if you just train on this part, yeah, it doesn't see like A and B. So a certified is gonna see the distribution that it has, like how many C it has, how many A it has, how many B it has. And it's gonna like say, okay, like this is the simplest way that I'm explaining, but it's more than this one. So for example, it says, okay, it has 5C, 3A, and I don't know, like 6C, 3A, for example, 2B. It says, okay, from this one, I should select 3 of C for train, 3 of them for like test, because like assuming we want to separate it to 2 parts. So 1B here, 1B here, and for example, 2A here, 1A here. What shuffling does, shuffling just like change the arrangement of the data, but it doesn't check the distribution. Like for example, its first row or second row is A. Like for example, we have like, for example, these are the, let's say these are like, okay, let me write it. Like, let's say we have 8 examples. This is number of examples. This is not the features or something. This is just ID of the examples. What shuffling does, just change these numbers. It doesn't care about like how many C it has or how many B it has. But shuffling basically does, for example, 1, 3, 2, like 5, 4, maybe it keeps the rest the same. And it's gonna be, for example, again here, it's gonna we have C, like B, C, A, C. And it's gonna like, for example, split it to 2 parts. Again, you can see that here, you don't have that much. Just make it simpler. Like, for example, if the shuffled IDs is like that, you can see here, again, you don't have a, sorry. But a certified is gonna like check the distribution. Yeah. Any other questions? But even the library has very good documentation. If you like, I don't know, later in a project or something, just, and there is a lot of like YouTube videos, if you are like find, like basically I would say any kind of machine learning example is gonna like be solved by this like library. Not deep learning questions, like machine learning questions. So the rest is like the using linear regression. But this is just something you can look at like later at home or whatever, because it's easier, like it's not harder. Please follow me. Yeah. I think if you don't have a question, you can leave, or because it's gonna like repeat whatever I already told. It's just provided for you if you want to take a look at home or yeah.